Hello everyone, welcome back to my channel. Myself Archit Kumar, and today we are going to solve LeetCode question number 605. Can place flowers? This problem looks a little confusing at first, but once you understand the pattern, the solution becomes very simple. Let's understand it step by step and solve it in CPP. Let's get started. So we are given a flower bed array here. 0 means the plot is empty and 1 means a flower is already planted. There is one important rule that we cannot plant flower in the adjacent plot. Our task is to determine we can plant exactly n number of new flowers without breaking this rule. So let's look at the example 1. The flower bed is 10001. Here n is equal to 1. So can we plant one flower here? Yes, we can plant it in the middle position. The flower bed becomes 10101. So the answer is true. Now let's think about how to solve it. So for any position, we can plant a flower only if the current position is empty, the left position is empty, and the right position is empty. So, but what happens the first and the last position? If we are at the first position, there is no left neighbor, and if we are at now, we can simply treat it as an empty. Similarly, we have at the last position. There is no right neighbor, so let's build the code. So first, let us traverse through the flower bed array. So here for int I equals to 0 and I less than flower bed dot size I plus plus flower bed dot size. Now let's check whether the current plot is empty. If flower bed of I is equals to 0, if we are at index 0, we will consider the left side as empty. So bool left empty is equals to I equals to 0 or flower bed of I minus 1 equals to 0. Similarly, check the right side. Bool right empty equals to I equals to flower bed dot uh, dot size minus 1 or flower bed I minus 1 equals to 0. Yes. If both sides are empty, we can plot a flower. So if left empty and right empty, we can plant the flower. So flower bed of I will be equals to 1. Now reduce the number of flower we still need to plant n minus minus. If we have already planted all the required flowers, then return true. If n equals to 0, we can return true. And if n is still greater than 0, it means we could not plant enough flowers. So we will return false. So I think the answer is correct. Let's see by submitting it. So here it have a mistake. Now let's verify that what's the mistake. So okay, so here it's a mistake here that we have closed our braces. So we will not close our braces here. We will close it here. Now let's submit the answer and see whether it is correct or not. So still there is a problem. Let me see it. Okay, so I have found the mistake here. The mistake is that first we have typed here I minus 1, but for the right side it should be I plus 1. With that, here is a typo mistake in left empty, and in the last I have by mistake written Z. Now let's submit the answer and check whether it's correct or not. So as you can see that it has passed both the test cases. Now let's submit the answer. So here it has passed 120 out of 130 test cases. The 10 test cases have been failed. Let me check whether what's the problem here. Actually, there is a loophole that what if n is equals to 0 initially, then also our code will return false. So for that we will give a condition that if n is equals to 0, return true. Now let's just check whether it's correct or not. Actually, the test cases will be the correct. Now let's submit the answer and see whether all the test cases has passed or not. So as you can see that all the test cases have been passed and we have surpassed 100% summation of by runtime here. Now here the time complexity would be O(n) because we are traversing the flower bed once, and the space complexity would be O(1) because we are using only a few variables. The most important lesson from this problem is that sometimes making the best choice at the current step leads to the correct answer. That's the basic idea behind the greedy algorithm. If you find this explanation helpful, make sure to like the video and subscribe to the channel. Thank you for watching. I will see you in the next video.